Hello everyone. Welcome to the next lecture on the PY question series. Today I will cover up all those questions related to the continuity of the function. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the CSIR UGC net and you can see the various PY question series on the different topics is available in this playlist. All these lectures are explained with the help of the fully shortcut. As I told you, my objective is we will cover all those questions, that is a 45 plus questions from the part B and part C related to the topic continuity in the real life. I will explain again all these questions with the help of the shortcut. As you know, the last lecture was on the limits. I have explained you the PY question on the limits. Today, I will explain you the continuity on the R, and the next two lecture will be on the uniform continuity and differentiability. I will upload these two lecture only if I get a good likes and the comment on this video. Now, what is the shortcut tips for you? Remember always, whenever you are working on the function from R to R, then your target is always to discard the option. Fine. And whenever you want to discard the option, your first step come in your mind is either of these three functions. Whenever the statement said it's a unbounded, bounded or unbounded, then you have to think about fx is my e raised power x, 1 or x function. Based on this, you can easily discard the options and those options which are left behind is your answer. If now since this is the continuity of the R to R, but if you want to find the how you can check about the continuity from R square to R, then for that you must watch about my previous lectures, that is a function of the several variable. This is the lecture related to the continuity, this is the lecture related to the differentiability of the several variable. However, if you want to combine the want to see the combined lectures on the continuity and differentiability, you must watch about either you are the part of the CSIR net or the GATE or the IT Jam. You must watch about my this lecture. I have explained many shortcut tricks in this lecture. You can find all these lecture at my YouTube channel. Kindly subscribe my YouTube channel so that you can get the notification when I uploaded my next video. You can also scan and join my WhatsApp group. Now let's start with the first question. F is a continuous function with the period P. What is the meaning of the continuous function? And the period P is f of x plus P is f of x. Then if I simply take P is my 2 pi and the function is my either the sine x or the cos x, that will satisfy the property. Then how you can solve this function? Firstly, your target is to check what is the gx. Can you integrate this function? If you want to take sin x, then again your choice. But if you want to integrate as such, then f of by the Leibniz rule, f of the upper limit into the derivative of the upper limit minus f of lower limit into derivative of the lower limit. What is the f of x plus p is f of p. So this part will be 0. That means gx will be my 0. Once gx is 0, every constant function is a continuous function. Every constant function is a differentiable function. But he said not a differentiable. Neither the differentiable a and b are my correct answer of this problem. Fine. Second method is if you want to take sin x and p will be my 2 pi, then this integration becomes my sine of t into dt. This will be my minus cos into t from x plus 2 pi to, so it will be cos of 2 pi plus x. It's a cos of x minus minus plus cos of x. Again, you can see it's a 0. Every 0 function, that's a constant function. Continuous function is a differentiable. So again, my answers are A and B are my correct answer. Consider the improper Riemann integral. Can you solve this integration? It will be my root y over 1 over y from 0 to x. This will be my 2 times root x. Fine. So if I call this is my integration I, so your answer will be I is twice of the root x. Fine. Now this integration is a continuous for all x in the domain. Fine. So it's a continuous in the closed interval. Fine. Continuous only in the closed open interval. That's wrong. Now they are talking about the discontinuity. Function is discontinuous in the 0, infinity. The function is continuous everywhere. Function is discontinuous only in this. The function is not discontinuous. So the right option is only A is my right answer. Now you can see it's a June 2023. Consider the function f from R to R defined by this, on which of the following subset of the R. So if this is my R, I call this is my subset. Fine. If I call this is my subset, define say A is my subset of the R, the restriction of the F is continuous. The meaning is your targets to define F in the A is continuous. Very simple, very simple. You can see it's a June 2023 and it's one of the simplest question. Look at this function. Clearly say when x this function, what will happen if limit x approaches 0 fx, the limit does not exist. Fine. You must watch about my last lecture on the PY question of the limits so that you can remember how you can calculate the limit. Clearly say that it's a sign of infinity, but it's a sign infinity is always lies between -1 to +1. And it is not a unique limit, so therefore limit does not exist. Once the limit does not exist, it means the function is not continuous. At which point? At x is equal to 0. So clearly say this function is only discontinuous at x is equal to 0. So what does it mean? My target is to make the continuous function. So what does it mean? It means if I prove that 0 does not belong to the set A, then the function is continuous. Fine. Now look at that. 0 belongs to this set. This option cancel. 0 does not belong to this set. Now look at that. This is not the set. So we firstly define the set. So it's a collection of all those elements in the form of 1 over n. We will find the function f of x. What is f of x? Is sine n into pi. And n is my natural number. So this number will always 0. This number will be my 0. This is already 0. So that means my f of x will be 0. So what does it mean? F of x is 0. So what can you say about that? Whether it's a continuous or not? F of x is 0. That is always the 0 function. So every 0 function, that's my constant function. Every constant function is my continuous. Now for this case, if x is my 1 over 2 raised to power n, then what will be my fx? If I substitute x is my this case, it's a 2 raised, sorry, sine of 2 raised to power n into pi. What is the n? N is my natural number. So 2 raised to power n is also my natural number. So this number is always 0. Every constant function is my continuous function. So which of the following are the right answer? B, C, D are my correct answer of this problem. Now look at the next question. F x comma y for the pair of this x and y are non-zero, theta is the unique real number such that minus pi is less than theta is less than of this. That is called as the principal argument. Fine. X and y are written in the polar form. Then the resulting function theta is. You know what is the in the polar form? What is the theta? It's a tan inverse y over x. Fine. Now tan is this one. So is a differentiable continuous. So firstly we will check about the continuity. How you can check about the continuity? I can simply take the path y is equal to mx. So theta will be tan inverse of m. So it depends on the m. That means it is not continuous. So once it is not continuous, it means it is not differentiable. So is the first option cancel, continuous cancel, not continuous fine. How you can check about the boundedness? So clearly say it's a tan inverse and tan inverse is my bounded function. So yes, it's a bounded function. Neither the bounded is not the right answer. So the right answer of this problem is C is my correct answer. Let x and y are my real numbers such that 0 is less than y is less than x. You can choose any number. Say y is equal to 1 because y is greater than 0. I can choose x is my 2. N is my any positive number. So say n is my 1. Any positive number. Which of the following statements are my correct? So if I take n is equal to 1, you can see it's a n minus 1 is a 0. So there is no significance for that. I can choose n is my 2. So then the first part will be 2, 1 raised to power 1 is 1, x minus y is 1 is less than equal to x 2 raised to power 2, 4, 1 raised to power 2. So clearly say first will satisfy. But this kind of the examples are only to discard the option. 2 into 2 raised to power 1 less than equal to 4 minus 1. It is not satisfied. This option 2 into 1 is greater than equal to 4 minus 1. It is not satisfied. This option 2 into 2 is greater than equal to 4 minus 1. That's satisfied. So that means we are thinking about the first and last option. But if you closely look about the A and the C option, they are the same, just are of the opposite signs, and we see that equality does not hold. That means if greater than sign is not possible, then definitely less than sign will be possible. Similarly, if you look about the B and D, they are again opposite signs. If I cancel the B, so D will be satisfied. So A and D are my correct answer of this problem. F is the continuous function, which are the following statement is my correct. Always remember, student, whenever you will see a function, a question related to the continuity, and f of x is equal to something, f of x is equal to something, then you always think about the fixed point theorem. Always, you always think about the fixed point theorem. You will get a very correct answer in a very simple manner. Now look at that. F is a continuous function. Then f of x is equal to x. Can you think about any of the function? Like as I told you, you always start from these three functions. Fine. Always start from these three functions. If I start from this, can you find a x? If I take f of x is x, then x is equal to x, definitely satisfied. 1 is equal to x, definitely satisfied 1. But if I take e raised to power x, f is my continuous function. If I assume fx is e raised to power x, then e raised to power x can never be equal to the x, because e raised to power x is this graph, x will be this graph. So that means this has no fixed point. So once it has no fixed point, that means this equality will not hold. Now clearly say, look at the last option. If I say x, if x has a fixed point, then it must be unique. That's wrong. If I consider f of x is x, then how many fixed points are there? If I choose this is my function, then it has infinitely many fixed points. So that means this option is also cancelled. Now, if f does not have a fixed point, unless it is differentiable, unless it is differentiable, can you think about the one function which is not differentiable, but still it has a fixed point? Very simple, very simple. What is the non-differentiable function that come in your mind? Mod x. Fine. So if I simply take mod x, x minus 1, what is the fixed point of this? 0. So if I add them, what is the fixed point of this case? Clearly say 1 is my fixed point, because if I simply choose this number, clearly say 1 will satisfy. So 1 is my fixed point. This is my non-differentiable function at x is equal to 1, and it does not has a fixed point, but we have a fixed point. So this option is cancelled. Only right option is my B is the correct answer. F is a non-constant polynomial of degree k. So you can choose the value of k. What is the degree of the k? Either you can choose as a 1, either you can choose as a 2, either you can choose as a odd function, either you can choose an as a even function. So I will choose both. Firstly, let's say k is equal to 2. Remember, your target is to discard the option. G is my any bounded continuous function. The easiest way you can choose as a 1. Fine. Then f is my polynomial of degree 2. If I choose x square, fine. There always exists x naught such that x square is equal to 1. That's always true. But if I choose x square is my minus 1, which is a bounded, which is a continuous, can you find a x which is belongs to the R? There does not belong to the any x in the R. So that option is cancelled. There is no x belongs to the R such that this will satisfy it. That's wrong. If I choose gx will be 1, so can clearly say x square will be 1. Definitely x is my plus minus 1, both are belongs to the part. He said there is no. This option is cancelled. There exists x naught such that k is even. So if I choose k is even, I choose fx is equal to x square. And then he said again, if I choose gx will be my minus 1. Again, there does not exist any r, any x in the r. So this option is also cancelled. The right option is which is left behind is D is my right. P of x is a polynomial function, the one variable of the odd degree. So what you can think, any function which is of odd degree is, say simplest one is x. G is my continuous function. So you can choose any function g, either the e raised power x, either the 1, either the x and so on. There exists a point P such that both are equal. Fine. You whenever there is a polynomial term, you always think about the fixed point. Now, can you choose, because px is my x, can you choose a g which is my continuous and there does not exist? You can see I have chosen instead of the x, I can choose a gx is my x plus 1. Can you find x which belongs to the R which satisfied this? There is no x which will satisfy this one. Fine. Or or you can choose, because g is my continuous function, you can choose g is my e raised to power x. Can you find the fixed point of these two cases? There is no fixed point. Again, the first option will be cancelled. Now look at the second option. G is a polynomial function, then there exists, if g is a polynomial function, I can choose g is my x plus 1. Then can you find a x, which x will satisfy this case? There does not exist anyone. So if this option is also cancelled. Again, you can see there is a unique point x naught such that this will be true. That means he said there is a unique fixed point. That is not true, because if I choose px is x, if I choose gx is also x, then how many points will satisfy this equation? Infinitely many. So that means there is a unique. It's not true. The only left behind is C is my correct answer. Remember student, your target is to discard the option. I hope you can like and comment on my this video. Okay, now you can see it's a June 2023. Consider the function f of xy is x square minus y cube. This is my function given to you. So that's a polynomial function. Every polynomial function is my continuous. Every polynomial function is my differential. But it is of my two dimension. There is no continuous real value function g defined on the R containing 0 such that f of x comma gx will be 0. Can you find the value of the gx? It's a x square minus gx cube is 0. What is my gx? Gx will be x raised to power 2 over 3. Now, what can you say about this function? This is a continuous function at x is equal to 0. Fine. But he said there is no continuous function which contains 0. That option is cancelled. There exists exactly one continuous function g defined on the interval containing 0. Yes, there is a continuous function. There is exactly one differentiable function. So if you find the differential 2 over 3 x raised to power 1 over 3, there exists exactly one differentiable function which containing 0. So clearly say this function is my non-differentiable at x is equal to 0. So that means there is exactly one function that's wrong. There exists a two distinct differentiable function containing 0, but at the point x is equal to 0 the function is not differentiable. So the right answer is my B is the correct one. And you can see your first target is to understand the problem or understand the question in a very simple manner. Okay, let f is the open interval 0 comma r to r such that fx minus fy is less than equal to sin x minus sin y. Fine. Now we all know sin x will be less than of the x. So I can say this number is less than of x minus y. So what does it mean? Fx minus fy over x minus y is less than equal to 1. What does it implies? F dash of x will be less than equal to 1. What does it means? That means f is my uniform continuous. Fine. Although I will upload the next lecture on the uniform continuity, but make sure I will upload only if I get the good likes in the comment. So I will tell you this result also. Whenever the derivative of the function is less than equal to 1 and the function is my this, then f is my uniform continuous. F is uniform continuous on the closing. So once f is the uniform continuous, this implies f is continuous on the closed interval 0, 1. So there is a discontinuous function. That's a wrong. F is continuous everywhere. That's a correct statement, but not uniform continuous. That's a wrong answer. Now, once because the interval is my open, fine, and F is my uniform continuous. So what is the rule is the limit of the lower 0 positive f and limit of x upper limit, that is a 1 negative, both existence minus f exists if this is if and only if f is my uniform continuous on the closed interval 0 comma 1. Now since I proved that f is uniform continuous, so that means this result hold. So the right answers are C and D are my correct option of this problem. Look at this another one. Again, you can see this is a similar question. So fx minus fy. Again, cos is less than of x minus y. Again, I can say f dash of x is less than equal to 1. So that means f is my uniform continuous. If f is uniform continuous, that means f is continuous for all x in my open interval. Now, once f is uniform continuous, the first option cancel, not a uniform continuous cancel. Third option is correct. Fourth option, once they are in the open interval, so that means limit x approaches 0, positive fx exists. That means this option is also correct. So again, the right answers are C and D are the correct answers. You can see before going to the examination why there is a need of the PY question. You can see it's a December 2015, it's a June 2015, just recent year, and this is the December 2019, and it's a 30 2020. You can see the similar kind of the questions occur in the subsequent years. So that's why PY question is a very important to solve before going to the examinations. Don't forget to like and comment on this my video. E is the subset of the R. Fine. Then the characteristics function. What is the characteristics function? 1, 0. 1 if x belongs to the my E and otherwise it is not E. Fine. Then the characteristics function is my continuous if and only if. Very simple. What is the definition of the continuous? That means limit x approaches to the point say A of xi E is exists. Fine. That's the meaning of the continuous. Now look at the option. E is my closed interval. So I can choose any closed interval. Say 0 comma 1. Fine. What is the graph of 0, 1? So if I choose E is my closed interval 0, 1. So inside this is a 1 limit, outside this is a 0. Now does it continuous? You can see what is the limit of x approaches 0 minus, and what is the limit of the x approaches 0 positive, because it's a closed interval. What is the 0 positive limit? 1. 0 negative limit? 0. Are they equal? No. That means the function is discontinuous, but we need a continuous if and only if the first option is cancelled. Second option, the function is my open interval. So I can choose E is the any open interval of say 0, 1. Fine. Inside the limit is 1, outside limit 0. Again, you can see this function is discontinuous at x is equal to 0. So that means the function is not continuous. This option is also cancelled. Or you can choose about this function. Fine. The function is either open, both open and closed. What is the function both open and closed? Can you tell me which set is? R. Function which is neither open nor closed. That's a wrong answer. So that means C is my right answer of this problem. Or you can easily provide the one example which is neither the open nor the closed, and then again you can see the function is not continuous. So the correct option is only C is the right answer. Now for a continuous function f from R to R, ZF is compact, open, connected, and closed. Very simple. Any continuous function, let's say I can start with the 1. Is it possible you can take f of x is 1? No, because I have to taken about all those values of the x at which fx is 0. So that means I can never take an as 1. Can you take f of x is e raised to power x? No, because e raised to power x can never be 0. What is the third example I have given you the earlier? F of x is x. Can you take an f of x is x? Yes. So that means your ZF will be collection of all those x in the R such that f of x will be 0. So what is the meaning of that? This is a singleton set. What is a singleton set? This is my closed set. So it is not open. Fine. Closed, so can be compact. Fine. So one option is cancel. Can you provide the any other example? Any other function whose f of x will be 0? Sin x? Fine. If I choose f of x is my sin x, then what is my ZF? ZF is collection of all those x such that sine of x will be 0. So what is the x? X will be my n pi. Fine. Where n is my natural number. So what is the ZF? That is basically a natural number. So natural number, is it a connected set? No. That is cancel. Clearly say what is the natural number? 1. Only the 2, 3. Can you go 1 to 2 directly without breaking the point? No. So that is not a connect. Now the rest two options. Now since it's a part B, because it is, so it means if I say it is a compact, if this option is correct, then every compact is a closed. So that means this option is also correct. But it's a part B, definitely the compact is not the correct answer. Closed is the right answer. But if you want, I can think about the one example easily. Can you provide the one example? So one is not satisfied. I can simply choose f of x is 0. Then what is the ZF? Which value of the x will satisfy this? Complete R, and you can see R is my not compact. That means this option is cancelled. D is my right answer of this problem. Always remember your approach in the examination is to discard the option. Don't try to find the correct answer. You are unable to find the correct answer within the 10 to 15-second time period. Now look at that. F is a monotonically increasing function. F is monotonically increasing function from 0, 1 to 0, 1. then f must be the continuous, f must be the continuous Riemann, and so on. Very simple. We are talking about the finitely countable. Do you remember any of the result which relates with the monotonic and the countable? Whenever f is monotonically increasing function, fine. So they are not talking about the continuity. Either the function may be the continuous or the function may be the discontinuous. You all knows that the mode of x or greatest integer of the x. Now, whenever the function is monotonic, then it has discontinuities. If it has discontinuities, then it always has the jump discontinuities. That is discontinuity of the first kind. Always. Every monotonic function has a monotonic function has a discontinuity of the first kind. And what is the nature of that discontinuities? It has every monotonic function has a discontinuity of the first kind, that's a jump discontinuity, and it has a countably many points. Fine. Now you can see that f is continuous at all, but f is finitely many, but we need a countably many. Second option is the correct. Now Riemann integrable. How you can check about the Riemann integrable? So before I can see directly, how I can say directly, you can see about my this lecture, Riemann integration. You must watch about my this lecture on the Riemann integration so that you can learn how I can say directly. Now since f is my monotonic function, fine. If f is monotonic function, it means f is my Riemann integrable function. Now once f is a Riemann integrable function, it means f is my Lebesgue integrable function. Make sure the converse is need not be true. But if f is Riemann, then it is a Lebesgue integrable. So the right answers are B, C, D are my correct answers. You must watch about my this lecture on the Riemann integration. Okay, f is my R to R is a non-decreasing function. That means f is my monotonic function. Fine, non-decreasing function, that's a monotonic function, and they are talking about the discontinuity. What I told you, the discontinuity is of my countable nature. So that means my discontinuity are of jump discontinuity and they are of countable nature. So that means how you can check about the countability. So for that you must watch about my previous lecture on the countability, PY question of the countability. So out of Z, we all know Z is a countable, N is countable, Q is countable, R minus Q, that is a irrational number which is not countable. So the right answers are A, B and C are the correct answers. You can see within the 10 to 15 seconds you can get your answer if you watch by all these videos with the proper intention and the manner. I have explained every shortcut tricks in these videos so that you can get your answer in your examination within the 10 to 15-second time period. Don't forget to like and comment on my video. Let f is the continuous and one function. Always remember again, you have to first choice of your will be from these cases. Then f is from R to R, which is continuous and on to. You can choose any one of them. Then f is on to. Clearly say if I choose the first function, clearly say it is not a onto because e raised to power x can never be 0 and 0 is the part of the domain. So this is my not onto. So based on this example, this option is cancelled. You can see this is the unbounded. Fine, f is unbounded, but if you choose f of x is my 1, this is my bounded function. Fine, so this option is also cancelled. What does it means? Whenever I, as I told you, whenever there is a equality about that, you have to always think about the fixed point. Now he said there exists a fixed point, there exists a x such that f of x is equal to 1. Can you think about the function? Can you think about out of this function whose there does not exist any x? Just think about that, any function which will satisfy this property. There exists a x. What value of the x I can choose it. If I choose e raised to power x, then it will be my 1 satisfied. But what will happen? I can combine them. Can this value be the 1? Can f of x be the 1? If f of x will be 1, what will happen? E raised to power x will be 0, and that is not possible. So that means there does not exist any x for this function. And clearly say this function is my continuous, this function is my 1, 1. So therefore the only left behind is my B is my correct one. As I told you many times, your target is to discard the option. Don't chase the correct option. Always move toward the discard the options. F is a continuous map again. So you can choose the example from e raised to power x, 1 or x. F is a bounded. Can you think about any of the function which is unbounded? If I choose f of x is my x, which is a continuous function, then clearly say this is unbounded because x approaches infinity as x approaches this one. So this is an unbounded function. The image of the f is the open set. If I choose f of x is my 1, what is the image of this set? What is the image is? Image is my 1, that's a singleton, and singleton set is always closed. It is not open. Fine. So that means it's an open subset of the R. It is not an open. Look at this one. F of A is bounded for all bounded subset A of the R. Is a bounded subset. If A is my bounded, okay, if A is my bounded and F is my continuous, then definitely F of A is also bounded. F of A is also bounded. F inverse is the compact for all compact subset. That means closed and bounded. That's the wrong. If I simply choose A is equal to R, then what is the F inverse of A? F is my continuous, this is R, and R is my not compact. Why it is not a compact? It's a closed, but it is not bounded. So this option is cancelled. Only left behind is my C is the correct answer of this problem. Now that's the C answer. Okay. A is the subset of R. Fine. Which of the following property implies A is compact? Which of the following property implies A is compact? That means closed and bounded. This is your target. Fine. This is your target to prove that. So which of the following implies? Every continuous function from A to R is bounded. This is given to you. What does it mean? Every continuous function is bounded. That means f of A is my bounded. If f of A is my bounded, that means A is my bounded. Fine. Now, if A is my bounded and the function is continuous, so definitely A is my closed. So it's A closed and bounded. So that means it's my compact. First option is the correct. Look at the second option. Every sequence in the A has a convergent subsequence. That's I think a standard theorem. What come in your mind when you are talking about the convergent subsequent? Which theorem will come in your mind? Bolzano-Weierstrass theorem. But he suggested you A is my, this A is my closed and bounded. Fine. If A is closed and bounded, that means A is my compact. Look at this another one. There exists a continuous function from A to closed interval 0, comma 1. Then A is my compact. Now since it's a closed interval 0, 1, which function come in your mind whenever you are talking about the 0, comma 1? Which function? What is the first function directly hit in your mind when you are talking about the closed interval? That's a sin x and cos x. Fine. So clearly say if I simply take A as a subset of R, if I choose A as my R, fine, then I can define the function from like of this. It is from -1 to +1. I need a 0 to 1. I can simply take the modulus. Clearly say this is my continuous. Fine. It's onto as well because it's from the R to this, but R is my not bounded. If R is not bounded, it means it is not compact. So this does not implies there. There is no, let me clear the screen. There is no one and continuous function from A on to 0 comma. There is no one. Can you define a function? Firstly, can you think about a function which is not, that's a simple, I think. I can choose, fine, fine. There is no one and continuous function. Clearly say there is no continuous. Why? Because if this is a continuous, we all know f inverse of the open set will give you the open set. Fine. So, but what is the f inverse of 0 comma 1? If this is onto if, then it will be by this number. Now it's a semi open, which is it open? No. So that means this is my not bounded, it is not compact. So there is no, that's the wrong option. So correct answers are A and B are my right answer of this problem. Again, A is the subset of the R, F is my continuous function. Always you can see that in each year examination paper, I have used these three counter examples. A is my closed, then f of A is my closed. Can you think about f of A is my closed? How you can provide the example, or can you think about that the function is not closed? A is the subset of R. So if I define the mapping from A to R such that f of A is my open, that means my interval will be like this. Fine. Now it's on the R. So I need an interval from minus infinity to plus infinity. So which function come in your mind when it is from minus infinity to plus infinity? F of x is equal to x. Fine. But in that case, A is my close. So if I say A is my close interval, okay, that's a simple tan inverse x. What is that? If I define the function f of x is tan inverse x, what will happen? This, what is the f of A? What is the range of this? Minus infinity plus infinity, which is my open, but he said close. You always look about the domain. You can see in this case, I need the closed interval. I have think about the sine and cosine. In this case, I need the minus infinity to plus infinity. I can think about the tan. You may think about any other example as well. If A is bounded, then F inverse is also bounded. F inverse is bounded. Can you think about that? Firstly, think about this. This is my bounded function because this is my unbounded, this is unbounded. Only function which is bounded is 1. So what is the f inverse of 1? This is my complete R. Fine. It is from R to R. Clear? Then this is my bounded because it's a singleton set. So every, if I consider A is my singleton set, which is a bounded, fine, and singleton set is the subset of the R also. Then what is the f inverse of A? What is the x? For which x it will be satisfied? It's a complete R, but R is my not bounded. So that means f inverse is bounded. Option cancel. Remember, your target is to discard the option. A is closed and bounded. That means compact. F of A is closed and bounded. This is happen only, we all knows, if f is my continuous function, then f map compact set to the compact set. So f of A is my compact if and only if f is my continuous, and that is a correct statement. If A is bounded, then definitely this, that is the same as I explained in the previous one. This is also bounded. So the right options are C and D are my correct answer of this problem. Look at this one. In which of the following case there exists a continuous and onto function? You need a continuous as well as onto function both. Look at the last one. This is the open interval 0 comma 2. This is my singleton 0 singleton 1. Can you map a continuous? This is my connected set. This is my disconnected set. If f is continuous, then f map connected set to the connected set. So this option will be cancelled. Fine. What is that? This is my compact. This is not compact. So if f is continuous, then we will map continuous to the continuous. So this option is also cancelled out. This is not a, this is a continuous, this is a connected, this is connected. It is not a compact, it's not a compact. Then can you define a map from 0 comma 1 to 0 comma open interval 0 close interval 1? There exists, we have to define only one map if possible. Let's try to define the map. My domain is 0 to 1. So continuous and on to. So I need a on to. That means I have to think about the function whose domain will be 0 and 1 both. Okay. I can simply say x. So 0 will map to the 0, open to the open. And if I choose as a 1, then it will not goes to the 1. So I have to break them. So then I have to break them, say 1 by 2, 1 by 2 to 1. Now since I need a equality also, so I can define as 1 this one. Fine. 1 will goes to the 1. Now in order to define the continuous, I can take it as a 2. Now you can see this is my continuous. Fine. 0 will be, half will be 1 and 1 is a continuous function. This is my continuous. Fine. Is it on to? Clearly say if you define the image, yes. Because if you simply take 2x is y, x will be y over 2. That's on to as well. So that means yes, A is my correct option. Now look at the last option. Can you define the map from open interval to R? So that means minus infinity to plus infinity. R means minus infinity to plus infinity. Again, as I told you, this is my open, this is my open. So this condition will be satisfied. F open will be F open. Fine. Now this is the minus infinity to plus infinity. So we have to think about the tan. Since I need the inverse image, so I can define the function like tan inverse of the x. Now I need a 0 and 1. Fine. So if I need a 0 and 1, I can simply take as pi by pi. Now infinity, when it will be the infinity? When it is pi by 2. So pi by 2 of x. So when it takes 0, tan 0 will be 0. Tan of 1 is infinity. But I need a minus infinity. So instead of this x, what should I take on? If I take x is 1, then it will go to the infinity. If I take x is 0, it will go to the minus of 1. So I can choose this number. When I take a 0, it will go to the tan of minus infinity. That's a minus of pi. If I take 1, it will be 0. So I can take it as a 2x. Then if I take 1, it will go to the plus infinity. Clearly say this is my continuous map. Fine. And it's a 2x minus 1 is a linear function. So this is on to as well. So the my functions are A and C are the right answer of this problem. Which of the following statement is or are correct? There exists a continuous map from FR to R. Now clearly say we all know F map from the connected set to the connected set. But you can see this is my, this these are not connected and disconnected, connected and disconnected. F map from R to R square, R to the polar coordinates. I can simply say any point cos theta, sin theta. Fine. Corresponding to the each point is a polar coordinate I can define, and this is my continuous. Since I need only the continuous map, there exists a continuous map from, so whenever there is a singleton, so this is my 0, so that is my disconnected set. Fine. I will check whether this set is disconnected or not. 0 to 1, and this is my 2 to 3. So clearly say this one and this one, they are not, 1 and 2 are not connected. So this is my disconnected, and we all know if f is continuous, then disconnected set to be my to the disconnected. So this option is also correct. C and D are my correct answers. Okay, look at that. F is my close interval to the open interval is a continuous map. Again, we can think about these examples needed. Which of the following statement is not true? So now this time we need a one counter example that's enough. Clearly say first of all this one. That's a fixed point. Fine. So can you define a function is a closed interval to this? Then there exists one x. So first of all, it is not from R to R. This is not given. It's from the closed interval to the open interval. What does it mean? Since 0, 1 is my bounded, fine. So that means if I apply the f of 0, comma 1, this is also bounded, fine. Because as I mentioned you in this, if A is bounded, f of A is also bounded. So now this is bounded. So by the fixed point theorem, what is the fixed point theorem suggested you? There exists at least one x such that f of x is x. It is a continuous. Continuous is given to you. Bounded you have proved. So there is a fixed point. So this statement is my correct statement. Now, last option is the open interval. Fine. This is my compact. Closed interval is my compact. And this is not a compact. Fine. It is not compact. So that means that there does not exist any continuous map. So that's true. There is a true state. Now out of these two, I have to discard the one option. F is the closed set. F is the subset of is my closed. Fine. Now since 0, comma 1 is my bounded is a subset of this. So that means F is my bounded as well. Fine. So F is closed, F is bounded. What does it mean? F is compact. So F is compact, F is my continuous. So F of capital F, compact set map on the compact set. So once f of f is my compact, compact means closed and bounded. So f is closed in R. This is also my correct statement. The only incorrect statement is my B is the correct answer of this problem. But how? Let's see if we are able to define the function. F of 0 is less than of f of. So I can choose f of 0 is my 0. F of 1 will be my no, it's an open interval. So I can choose f of 0 is my 0.1 and f of 1 will be my 0.9. So 0 will be my 0.1 and this is my 1 is my 0.9. So it's a continuous function. It can be like of any one of this. Then f of 0, comma 1 must be equal to f of 0 must be equal to this. That's not true. You can see this is my 0, this is my 1. Fine. So it may happen that the function is a continuous which are defined like this manner. Fine. And any point which are lies in between this, say x is my half. Then what is my f of half? F of half is a this number. This number is my 0.9. So definitely this number will be my 2. So f of 0, comma 1 will be my 2 is must be equal to close interval of 0.1 and 0.9. This is not equal. So that's why this is my false statement. Okay, look at this another one. F and G are my continuous functions such that now once the points are given, we can define its graph. F of 0 is 0, f of 1 is my 1. And the functions are my continuous, so it can be of like this way. Fine. Maximum value is not given, so it can be anything. G of 0 is my 1. So it may be 1, it may be more than 1. So I can assume any number this point. This is my 1. G of 1 is also 1, and it is my continuous function such that f of half, this is the value of the f half, is greater than of the g half. Now there are the two cases. Find this the value of the f. Fine. What is the nature of the g? G may be of this form because it's a continuous. It may be of any one of them, or G may be of, this is my G1. It may be of this form, but it can never be reach above of these points. Fine. Means G, it may be the decreasing or it may be the increasing. Fine. Now if I consider this case, how many points they intersect? At least 2 points. And on this case, how many points they intersect? 2 points. So there is no t such that they are equal. That's the wrong option. These are the points where the functions f and g are equal. There is exactly one point. Cancel. There are always infinitely many points. Wrong. There are only the 2 points. Exactly 2 points. C is my correct answer of this problem. F is a continuous function such that t varies from 0. F of x dx is 1 to t f of x dx for every t defined like this way. You can choose any counter example. Let me check whether f of 1 will be satisfied. What is the left integration is t, right integration is this. They are not same. Fine. If I choose, because f is any continuous function, if I choose a 0, then clearly say 0 and 0 will be satisfied. Now 0 is a differentiable, but this is a one counter example. We can't correct this option. Look at that. Third option cancel out. Because what is the integration of the 0? It is 0, which is not 1. F of x is greater than 0. That also cancel. Now how you can check about the differentiability? We can integrate them, or we can differentiate. How you can how you can integrate that? So the one way is we can differentiate both sides. So how you can differentiate? F of upper limit into derivative of 1 minus f of lower limit into derivative of 0, which is equal to f of upper limit into derivative of 1 by using the Leibniz rule minus f of lower limit into derivative 1. So that will give you f of t 0 0 minus f of t. That means f of t will be my 0. So once it's a 0, that's a 0 function is my constant function. Every constant function is a differentiable. Every constant function is my monotonic function. So A and B are my correct answer. Okay, look at this one. F is given to be this. F is bounded, continuous, not well defined, not continuous. Clearly say x square plus t square will never be 0. Fine, because t start from 1 to infinity. Also cos of t. So once this is non-zero, then this number is well defined. Fine. Once this number is well defined, the integration is also well defined. So the function is not well defined is the cancel. Continuous or not continuous. How you can check about the continuity or bounded? Firstly, we can check about the bounded. Or how you can check about the continuity? Since this is my polynomial, fine. This is my trigonometric function. Both are my continuous. So that means this is also my continuous. So f is continuous, f is not continuous. Cancel. How you can check about the bounded? I can start with the modulus of f, that is 0 1 to infinity cos of t divided by x square plus t square. How you can integrate? Modulus of integration, it is less than of mod of cos divided by x square plus t square into dt. Since cos value is less than of the 1, I can return this, and x square plus t square is always greater than 0. So modulus value is my positive. Can you find the integration of this? It is 1 over x tan inverse t over x from 1 to infinity. So that means 1 over x If you substitute infinity, it's a pi over 2. If you substitute 1, it's a tan inverse. So that number I can say mod of f is less than equal to 1 over x cot inverse 1 over x. Fine. Or I can also be written as this is my tan inverse x. Fine. Now clearly say we all know tan inverse of x is always be less than of x. So this number is less than of 1. Fine. So 1, when this number is less than 1, it means it is my bounded function. Otherwise, if you are unable to remember this, you can start with this limit. Take x approaches infinity. It's infinity by infinity. You can take the derivative. It's a 1 plus x square over 1. So clearly say this will goes to the 1. Again, it's a finite number. So the correct options are A and B are the right answer. Consider the which of the following function has a f is my continuous and f circle f is my f. So firstly, we can check about the continuity. -1 is a +1. -1 is a +1. 1 plus 1 plus 1. This is my continuous. 1, 1, 0, left limit, right limit, satisfied. -1, -1, +1 plus 1, continuity satisfied. -23 plus 1, -23. No, it's not a continuous because once you take f of -23, it is my +1. But if you taken from this side, it is my -1. This is not continuous. That means you can see limit x approaches -23 negative, limit x approaches -23 positive. They are not same. It means the function does not, limit does not exist. That means the function is not continuous. Now, these all are my linear. Fine. Once they are linear, this will be satisfied. Since this is my non-linear, so you can choose any number. I can choose any number, say x is 2. Then what is the f circle f? It is f of 2. What is the f of 2? 2 lies in this case. That means f of 4. What is the f of 4 is 16. But what is the left hand side? And what is the right hand side is 4. Clearly say they are my not equal because this is my non-linear. So this option is cancelled. C and B are my right answer. If you want to check, you can easily do that, but they are the linear, so there is no worry about this composition. Okay, which of the following statement is my correct? F is the mapping from R2 to R. Fine. There are at most countable. They are at most countable. Again, you can choose about the function of ex, 1 or x. So this is a two variable. I can choose any constant function. Fine. I can simply say alpha. Fine. Where alpha is my r and clearly say there are countable, but r is my uncountable. There are at most finitely many continuous functions. Finitely many continuous subjective. Okay, there is no need. Okay, if you want to solve this manner also, you can choose any say 2x. It is my onto. Fine. It is my continuous, but finitely. So instead of this constant 2, I can choose it as a c, where c belongs to my r. Fine. Or cx plus d, any linear polynomial where c and d are my r. So this is my, are they finitely? They are uncountably, so they are cancelled. There are finitely many injective map. Again, you can define as a single x. They are infinitely, but you can see there are no continuous bijective. What is the meaning of the bijective? A to B. That means how many maps we can define is cardinality of B raised to power cardinality of A. So what is the mapping? What is the cardinality of R? Is a C. Cardinality of the R square is C cross C, that's a C. So but C raised to power C is my not a finite number. Fine. Moreover, it is not a countable. So that means there are no bijective map. So the right answer is D is my correct answer. Don't forget to like and comment on my video. F is a monotonic function. But what is the nature of a monotonic? It is not given to you. Fine. It may be the decreasing function. It may be the increasing function. Such that f of 1 by 4, f of 3 by 4 is less than 0. Let me quickly know what comes in your mind when you see this term. Apart from this statement. That is a yes, intermediate mean value theorem. That is, we have to think about the bisection method, regular falsy method, and so on. But remember that intermediate mean value theorem suggested only if f is continuous and f of a, f of b is my less than 0. What does it mean? There exists at least one c which are lies between a and b whose c will be my root. That's the intermediate value theorem. Can you read about the third statement? F is a continuous. There exists a root between 1 by 4 and 3 by 4, that is alpha, such that f of alpha will be 0. So third option is the right answer. Now, f of 1 by 4, what is the meaning of this? You have the two case, either f of 1 by 4 is less than 0 and then f of 3 by 4 is my greater than 0. Second case is either 1 over 4 is my greater than 0 or 3 by 4 is less than 0. Fine. Now we can draw it graphically. Say this is my 1 over 4, this is my 3 over 4. Now you can see in the first, second and the fourth part they are not talking about the continuous. So that means we can think about the discontinuous function firstly. Let's see. Firstly, I can assume that f is my increasing function. Fine. So I have to think about the first part. If f is increasing and you can choose any one option. Let's say f is negative. So this point is my here. F is my positive. This point is. And I choose f is my increasing. So that means I can choose this is my increasing and this is my. And I can choose this number is just wait. I can choose as a proper method. So I can choose as a discontinuous function. This f is my negative, this is my open, and this is my close. Fine. I have choose a function f of x is this line whenever it is less than of 3 by 4 and greater than equal to 3 by 4 is this number. Now, supremum of all those x which lies between the closed interval 0 comma 1 such that f of x is less than 0. F of x is less than 0 means which interval? 0 comma 3 by 4 open it because I have chosen 3 by 4 as a positive. So fine. So can you find the supremum of this? That supremum will be my alpha according to the statement. So can you find the alpha? What is the supremum of this? Supremum is 3 by 4 and once it's a 3 by 4, what is the f of 3 by 4? Is my positive number. But he said negative number. This option is cancelled. If f is increasing, but they are not talking about the increasing or decreasing. He said f of alpha is less than 0, but I get a fine. Now think about the decreasing function. What will happen if f is decreasing function? So then this is my 1 over 4. This is my 3 over 4. Again, I have choose the discontinuous function. Then if I choose f is my 3 by 4, this is my positive. Then you are unable to draw the decreasing function. Then it means my graph will be here. F of 4 will be positive. F of 3 by 4 is negative. Then f of alpha is always negative. You can see I can choose up to this one. Fine. Because it's a strictly less than 0. And after that I have decreased them. Then what is my alpha? Alpha is my supremum of all those values which are less than 0. That is open interval of 3 by 4 comma 1. Fine. So what is the supremum of this? Supremum will be my 1. And what is the value of the f of alpha? What is that? 1. The value of the 1 is my negative. So that means f of alpha is negative is the correct answer. Right? So that means the right options are C and D are my correct. This is a simple way you have to draw it graphically. Okay, this is December 2023. Which of the following functions are true? Very simple. It's a discontinuous and so on. We can find the limit. What is the value of the limit x approaches 0 negative? Because this is my bounded function. It's a greatest integer. So again, the limit is 0. Fine. This is my 0. So what is the function? Is my continuous. Fine. But he said discontinuous. Function is discontinuous and removable or not removable. What is the limit of x approaches 0 negative? So what is the log of 0 negative is minus infinity. So sine of minus infinity. That means limit does not exist. Fine. And which is not equal to f of 0. So that means the function is my discontinuous. Fine. Is it removable? When it will be the removable? It is removable only when this limit exists. Fine, but this limit is does not exist. So yes, it is not removable. So this option is the correct one. Jump discontinuity. That means we have, what is the meaning of the jump discontinuity? We have to prove limit of the 0 negative, limit of the 0 positive, both are exist and not equal. Fine. That's the continuity, discontinuity. So what is the 0 negative? 0 negative is e raised to power 1 over x. So what is the e 0 minus is 1 over minus h. As h approaches 0, I have taken x is 0 minus h. So what is the limit of this? E raised to power 0, that is 1. No, sorry, h is 0. So 1 over 1 over 0 is infinity minus infinity. So 1 over infinity will be 0. So this limit will be 0. Can you find the right hand limit? 1 over x plus 1. If I take the limit h approaches 0, it will be 1 over h plus 1. As h approaches 0, so it will be my e raised to power 1. Both are my finite number. This is finite, and they have the jump discontinuity. Yes, it has the jump discontinuity. Last option is, if f and g are my two bounded variation, then the product of the f and g are most countable. That's also the correct statement. How? You can see about my this lecture, bounded variation. All those shortcut tricks related to the boundary variation is available in my playlist. So the right answers are my B, C, D are my correct answers. Okay, look at this another one. The function is 1, 1 and on 2. So firstly, I will give the shortcut tricks. Fine. Now, if f is the mapping from A to B is 1, 1, then cardinality of A is always greater than of the cardinality of B. Fine. But make sure converse need not be true. But if cardinality of A is not greater than of the cardinality of B, then it is not 1. Fine. Second thing, whenever you are talking about the and, if it is onto, f is onto, then cardinality of A must be less than of the cardinality of B. And if whenever they are not true, then it is not 1, 1. Make sure the converse need not be true. But if this condition holds, then it is true. This is the first step. How you can check about the 1, 1. Second is, you can also check by graphically. If you draw the graph, say any graph, if you draw the horizontal line parallel to the x-axis, if it cut only one point, if it cut only one point, then it is 1, 1. For example, we all know x square is not 1, 1. You can check it graphically also. If I draw the horizontal line, it cut 2 points, but we need only 1 point. So this is not 1. Fine. Now, how you can check about the onto? That's a reverse. If you draw the vertical line, if it cut only the 1 point, then it is onto. Now let's see this question. Because this is my graph, I can easily draw the graph of this because I need a 0 to 1. Fine. This is my A. What is my B? X cube. So x cube is my, what is the graph of the x cube? This is the graph of x cube, but we need only from the 1 to 2. Sorry, it's a 1 to 2, not from the 0. So it is my Let me, this is the graph of x cube and this is the graph of 1 to 2. Fine. Now you can check it horizontally. If you draw the horizontal line, it cut 1 point. So this is my 1 1. If you draw the horizontal, again it cut the 1 point. That's a 1 1. If you draw the vertical line, it cut only the 1 point. This is the onto as well. This is also the onto as well. So there is a 1 1 and onto function. Yes. No 1 1 cross. No 1 1 cross. No onto cross. You can see within the 5 seconds you can solve this problem. I hope you can like and comment on my video as well. It's a June 2019 and it's a June 2011. Consider the function f, then which of the following statement are true? F is not 1 1 if the graph of the f intersects some line parallel to the x-axis at least 2 points. Yes, the same as I told you, because it cut the 2 points, then it is not 1 1. Yes, first statement is correct. F is 1 1 if the graph of the f intersects any line parallel to the x-axis in at most 1 point. That means unique point. Yes, correct statement. F is onto if the graph of the f intersect line parallel to the every line parallel to the x-axis. No, it must be the parallel to the y-axis. F is not one onto if the graph of the f does not intersect at least 1 point parallel to the x-axis. Wrong. It must be the parallel to the y-axis. So the right answer is A and B are the correct answer. Okay, which of the four? That's a very short. The same question I have explained you in my PY questions of countability. All those other questions which are related to the 1 1 and on to, you must watch about my this lecture on the countability. What is the shortcut fix is? If f instead of the f circle g, if f circle g is my identity, fine, then this f will be my 1 1, this one will be my on 2. Fine. Now, according to this, you can see f circle f is my identity because it's mapped from the x to x. So what does it mean? This will be my 1 1. This is my on 2. So what does it mean? F is my 1 1. F is my on 2. What does it mean? They are my bijective. F is 1 1 and on 2 fine. Not on 2 cancel, cancel, cancel. So A is my right answer of this problem. So you can see it's a very simple approach as I told you in my previous video. Okay, F is a mapping from Q to R which are defined 1 1 and on 2. We all knows what is the cardinality of Q. Alpha naught. Cardinality of R is C. So clearly say cardinality of Q is not greater than of the cardinality of C or R. Fine. Alpha naught is not greater than of C. So what does it mean? If whenever F is a mapping from A to B, fine, F is on 2 if cardinality of A is less than of the cardinality of B. But this condition not hold. That means this is my not on 2. So F is on 2, cancel, but on 2 cancel. Fine. If it is a 1 1, then it's a reverse state. Now, cardinality of A is cardinality of A. Now, what is a 1 1? Now, since this is less than of satisfied, but converse is not true. Fine. Now, what you can say about the 1 1? So, that's again very simple. I can choose any 2 points. R is my P over Q. P and Q are my GCD 1. I can choose 1 over 2. GCD is 1. So, this will be my 1 over 100. Fine. So, can you choose any other answer whose it will be 1 over 100? So, 1 over 100 will be, if I choose 10, 3. So, clearly say 10 and 3. The GCD is 1. Both are same, but 1 over 2 is not equal to 10 over 3. So, it's not 1, 1. So, neither the 1, 1 nor the on 2 is my right answer of this. Okay, December 2023, f is a continuous function such that f is okay. Think about the any function. Again, e raised to power x, 1 or x. I can choose as a x simple. Fine. So it will be x minus y is greater than equal to log of 1 minus 1 plus x minus y. So that's always true. If I choose h will be my x minus y. So then it will be h is always greater than of log of 1 plus h always, that is 2 always. So that means the function I have chosen f of x is x. This is a 1 1, but he said need not be 1 1. But the first option necessary, we can't say this is a one counter example. This is the onto as well on the R2R, but he said need not be on. Fine. Now, how you can check about this first and the third option. So f is 1 1. Firstly, we need to check about the 1 1. If I assume x is equal to y, then my target is to prove fx is fy. Fine. Or I can choose fx is equal to fy. Fine. I can assume fx is equal to fy. Then this will be 0. That means log of 1 plus x minus y will be less than 0. Fine. So that means 1 plus x minus y will be my 1. Log of 1 will be 0. Fine. So that means x minus y will be 0. So the only case will be this. So that means f is necessary 1 1. Fine. So now f is continuous plus f is 1 1. Now, you can now I can check about the bound fx minus fy divided by x minus y. It is because x minus y is always positive, so the inequality will not be changed. Divided by x minus y. Now I can take the limit x approaches to the y because the left hand side will be my derivative. Fine. This will be, I can simply take this is my h approaches 0. I can take h is my x minus y. It is log of 1 plus h over h. So it's a 0 by 0 form. I can apply the L'Hopital rule. So this is my 1 as h approaches 0. F dash is my greater than equal to 1. That means f dash is my monotonic function. Also, f dash is my greater than equal to 1. That means it is my unbounded. That means this is my monotonic plus unbounded function. Fine. So the function which is continuous, which is 1 1 monotonic and unbounded, what does it mean? F is onto. Because once is unbounded, it will map minus infinity plus infinity. So that's the range of this. So f is onto is also the correct answer. So A and C are my correct answer of this problem. Okay, let X is the matrix space and F is my this case. You can define any of the matrix. Say it's on your choice. Again, your target is to discard the option. Fine. And I can define X is my R. Fine. Again, I can start with the 1. So then this function, distance of f of x is 1, f of y is 1, it is less than of x comma y. So that means this is 0. If I taken as a distance, it will be, it is 2, satisfied. Fine. So that means f of x is equal to 1, satisfied. So does it a 1 1? It is not 1 1. Fine. So f is injective, cancel. Fine. Now, is it a onto? Again, if I simply choose x is r, is it a onto? Clearly say this is a not a onto. Fine. If I choose this function fx minus fy is less than equal to x minus y. So clearly say what does it mean? If I divided both sides by mod of x minus y, then it is derivative is there. So that means f is my UC, uniform continuous. That means f is my continuous. That option is correct. Look at the last one. If and only if. If and only if 1 1 and on 2. Your mapping is from R to R. Can you think about graphically? Because you need a on 2. That means you need a complete range. Fine. Now you need a 1 1. How you can prove or disprove the 1 1? If I draw the horizontal line, it cut only the 1 point. I can define in such a way. One axis like this and say this number. Fine. It complete one, 0, 1, and so on. It taken complete value from minus infinity to plus infinity. This is on to fine. Is it a 1 1? No, because if you draw the horizontal line, it cut 1, 2, and 3 point. But we need only 1 point. If and only if not sense. Fine. So the right option is only A is my correct answer of this. I hope you can like, comment, and subscribe my YouTube channel. I hope also you have learned many easiest way to solve the functions and the continuity PY. I will come up with the next lecture on the differentiability. Till then, you can share this video with your friends. Best of luck, students. Happy learning.